So looking at part 2, it's not immediately obvious what to do here. We've got a bit of a problem in the fact that we've got a 2 on the right-hand side. Now, if that was equal to 0, I could rearrange the equation and form tan theta, because sine theta over cos theta is identical to tan theta, and then I could solve it that way. But the 2 is preventing me from doing that. If I subtracted 2 from both sides to create a 0, it wouldn't get me anywhere either, because I'd have that constant term spoiling things. So this is a problem. And if we look at the left-hand side of this, my only option really is to consider a harmonic function, because I've got terms containing sine and cosine. Now, what do I mean by that? We're going to have to look up an identity from the formula booklet. Okay, and I want to write the expression in blue in this form. Okay, I can tell it's that because I've got a subtraction in the middle here. Okay, so that sort of tells me to use a negative sign here. You can use the cosine version as well, but the sine of a minus b kind of makes sense. You can use the others, but I'm going to go with this. And just writing out the identity in full, this would give us r sine a cos b subtract r cos a sine b, like that. And the right hand side is analogous to this expression here. Okay, so let's have a look if we can equate coefficients. So if we set this up, we're going to have 5 sine theta subtract 5 cos theta is identical to r. Now I'm going to put a is equal to theta, cos b subtract r cos theta sine b. Now then, looking at each side, if we look at the amount of sine theta we've got 5 on the left and we've got r cos b on the right. So I can form an equation in terms of r and b. So we've got 5 is going to equal r cos b. And looking at the amount of cos theta I have, I've got 5 here. I'm going to ignore the negative sign because I also have a negative sign on the right hand side, so that doesn't matter. So the cos theta coefficient of 5 has to correspond to r sine b. So I'm going to write that down as well as my second equation. So I'm going to have 5 is equal to r sine b. So this is going to be equation 1. This is equation 2. I can solve them simultaneously by dividing 1 by 2. Other way around, sorry, 2 by 1. So 2 divided by 1 is going to be as follows. It's going to be r sine b divided by r cos b, which is equal to 5 over 5. So that's going to be 1. The r's cancel, they're non-zero. So we're going to have tan b is equal to 1, which implies that b must be 45 degrees. I'm working in degrees here, as it says at the start of the question. So we've got b, and then in order to find out what r is, you can sub that into the equation and rearrange it, or you can use Pythagoras' theorem on the coefficients. So it's completely up to you. The standard way to do it, which I might as well do, is to square equations 1 and 2. So we would have 25 is equal to r squared cos squared b, and then 25 would equal r squared sine squared b. If you add the equations together, okay, we would get 50 would be equal to r squared, and then we would have sine squared b plus cos squared b, which is of course 1. Okay, so we have r squared, which is 50, so r is root 50. In other words, if r is root 50, we can simplify that a little bit. So that implies that r is going to be 5 root 2. Okay. So what does that get us? Well, it means that because we've found what b and r are in that order, we can replace the r and the b in this part of the identity with what we've just discovered. We set a to equal theta earlier. So I can now say that the expression here that I started with is absolutely identical to r, which is 5 root 2 multiplied by the sine of theta subtract 45 degrees. Okay. And that's really helpful because according to our equation, this is all equal to 2. So I can now replace this equation with 5 root 2 sine of theta subtract 45 degrees, which is equal to 2. If I divide both sides by 5 root 2, I've got sine of theta subtract 45 degrees is equal to 2 over 5 root 2. And at this point, I can then solve using a cast diagram. So now I've set x equal to theta subtract 45. I'm going to be solving the equation sine x equals 2 over 5 root 2. This will get us our principal angle. So it's a positive amount, so I don't have to worry about the sign here. So for the principal angle, we have x is going to be the inverse sine of 2 over 5 root 2. Okay, so we do this on our calculator. So we'll say shift sine. I'm on degrees, so that's okay. 2 divided by, in fact, I'm going to do that as a fraction, I think, inverse sine of 2 over 5 multiplied by the square root of 2. Okay, just finish the bracket off there. Just check you've inputted everything correctly and you're on the right calculator setting. So this is 16.43 degrees. I'm just going to write this to 2 decimal places so we don't have a rounding issue later. So back to the main screen. So that's 16.43 degrees to 2 decimal places. Okay, that's our principal angle. We're working in the interval from 0 to 360. So we might have to make a little adjustment to our interval here. Going from the 0 to 360, including 0, well, we have to subtract 45 from everything. So we're actually going to be looking from negative 45, subtract 45 from theta, up to 360, subtract 45, which is going to be 315 degrees. Okay. So that's my interval I'm going to look in. Obviously, the theta subtract 45, that's the same as big X. Right. So I think we've got everything we need to do the cast diagram now. So just for the sake of space, I'm going to do the cast diagram over here on the left. So we've got C, A, S, and T. We've got the angle. We just need to check which quadrants we're going to put our principal angle in. So we look at the sign, as in, is the value positive or negative that we're equating? Well, it's a positive value, isn't it? So we have to use the first 2 quadrants. So it's going to go in here and here. So we have 16.43 degrees and 16.43 degrees as well. And just so you're aware, the interval we're going to look in starts at negative 45, which is here. So it starts there and goes back round until you get back to the 315. It's not going to affect the angles we're dealing with because they're in the first two quadrants, okay? But it sometimes can affect it. It may capture an extra angle or remove an extra angle depending on what your principal angle is. So just be aware of that. So let's have a look at our solution. So reading off from the cast diagram, we're going to have big X is equal to 16.43 degrees. And then we also have to subtract that from 180. Okay, so we do 180 subtract our answer, which is 163.57. Just check that. Okay, now those are to 2 decimal places. You have to give your answer to 1 decimal place. I've not finished yet though. I need to get theta, okay? Remember that X is theta subtract 45. So I need to add 45 to both of these solutions, okay? And then I'm going to round to 1 decimal place. So this is equal to theta subtract 45 degrees, okay? So my theta is going to be, so if I add 45 to both these angles, so plus 45, so that's going to be 208.6 for the second one. Okay, and for the 16.43, so add 45 to that. I don't trust my own arithmetic. So that's 61.43 for that one. Now that will round to 61.4. Okay, both of those to 1 decimal place. Okay, so that was quite a task. For 5 marks, there's a lot of work going on there. These questions will always say as well, solutions based entirely on graphical or numerical methods are not acceptable. So you can't use trial and improvement in this situation, okay? You've got to follow the procedure that I've just outlined.